Hello, welcome to a video where we are working with an exponential formula. In this video, we just have two pieces because as I read the problem up here in the blue portion of the screen, it gives me a formula to work with, so I do not have to write my own formula for this problem. So cholera, which is an intestinal disease caused by a bacteria that multiplies exponentially. The number of cholera the bacteria can be calculated using this formula given to us here, where T is time in hours. So in the orange box, if we introduce 2 bacteria to a petri dish, how many will there be in 12 hours? So knowing that we're introducing 2, that would be my starting number of bacteria. So that's going to go into this formula for P0. And reading that there are 12 hours, that is a time, so that's going to go into the formula for T. So the population at some later point in time is going to be 2, replacing the P0, E 1.386 times 12. Now I was almost going to put parentheses there, but I really want some other symbol for multiply because the parentheses get confusing when I type on my calculator. So this is calculator friendly, and we just go start typing. So we're going to type 2. Then we need to get E. So we have 2 buttons to use. So we're going to type second. And then we're going to use the LN button that is like 2 buttons below the second. And that will show up on our screen as E, caret key, parenthesis. So it's all ready for you to type in the exponent. And so we'll type 1.386. Here's where we want to type multiply and 12 and then close the parenthesis, which is why I don't want to use parentheses for multiplication and writing this. So I'm typing that on my calculator here, and 1.386 times 12 and parenthesis. And whoa, that is a huge number. So let me write this down. We would have 3, 3, 4, 3, 6, 1, 1, 5.65. All right. Probably want to round to a whole number because it's bacteria, so that seems like there either is one or not. So whole numbers here, this would round it up. So 3, 3, 4, 3, 6, 1, 1, 6 is the whole number. And add some commas so we can even read that number. So 1, 2, 3, 1, 2, 3. So that looks like 33,436,116 bacteria. That's kind of disgusting. Just thinking of that. If you start with 2 and you wait 12 hours, it multiplies to be in the millions. Crazy, crazy stuff. All right. So then we're asked our second question over here in the gray box, and that is, how long does it take for the number of bacteria to double? So this is an interesting question because it doesn't give me a number to plug in. It has this idea of double. So I go back and I'm thinking about what we did here in the orange box, and I saw that we started with 2. And so from there, we want to double that. So we're going to take those original 2 and multiply it times 2. And so we have 4 as our ending amount. Now, the really cool thing with these is that you can pick any pair of numbers that work. So if you didn't have this orange box in front here saying, hey, we're going to start with 2, you can be like, I'm going to start with 5. And so if you want to, you can start with 5, and then you're going to take that and double it. So 2 times 5 means you're going to end with 10. And it doesn't matter what pair of numbers you use as long as whatever you start with gets doubled. So let's use the second one just for fun. So we'll do this one as R1. So 10 is our ending amount. That goes into our formula for P of T. So that is the population later in time. 5, we're using that as our starting amount because that's what we picked. And so I can plug these into my formula. So 10 equals 5e 1.386t. And it asks me how long, and how long would equal a time, and that is my variable t. So I could solve this by hand using algebra with a logarithm, or I can use Desmos. So I'm going to use Desmos. Desmos needs me to have two equations. So on the left-hand side, this is saying that the y value is 10. And on the right-hand side, this is saying the y value is this formula. And so now I need to find Desmos. And I have so many screens open, I think I have lost Desmos. So let me Google that and get it back. Sorry for that delay. I've gotten it back. So here comes Desmos, and we'll make it small enough that we can see both screens here. And so the first equation that we're typing in Desmos is y equals 10. And the second equation that we're typing in is 5e, and we can get the e and the caret key right off of our keyboard, 1.386. And we have to use an x instead of the t. And so here, with the current zooming, I see the second equation, the one in blue, and I can clearly see that's a curve, and I do not see that one in red, so I'm going to zoom out a bit. Oh, one zoom out, and there I see it. So if I look at where they intersect, that ordered pair is 0.510. I'll take Desmos away there. So my ordered pair is 0.5, 10. And I know this is the x, this is the y. And I know that I used x right here instead of t. And so my time is 0.5, which is the same as 1/2 hour. So the number of bacteria for cholera will double every half an hour. So however many I put into that petri dish, half an hour later, I'll have twice as many. And so again, in this problem, we did not have all three steps because the formula was given, but we had step 2 there in orange using our calculator, and outcome 3 solving using a graph.